Good morning everyone. I am Supraja working as assistant professor in EEE department. Today I am going to discuss about basic concepts in electrical and electronics engineering. Like what is charge, what is voltage, current, power, energy, and some basic concept resistor, inductor and capacitor. Now let us start about what is a charge. In a conductor is a device which allows the current to flow through it. Let us take an example. This is a conductor. Conductor is having some particles inside it. We can call it them as electrons or charge. The particles have some ability to move or to flow when it is applied to the electrical field or magnetic field. The particle has a ability to move when it is applied with a electric field or magnetic field. Charge is denoted with the letter Q and units of charge is coulombs. Charge is nothing but the particle which experience force when it is placed in the magnetic field or electric field. Then what is current? What is electric current? What is electric current? Current is the flow of charge or flow of electrons. In a conductor, the particles have placed randomly. The electrons are placed randomly. Whenever we apply electric field, the particles will experience some force and they start moving. The flow of electrons. The flow of electrons or flow of charge is known as electric current. So electric current is denoted with the letter I is equals to charge by time, rate of charge by time. Its units are ampere. Charge is also denoted with letter I, dq by dt. Coulombs per second or amperes. I am the charge. When there is no electric field and no magnetic field, I am stationary. I does not have any movement. When external electric field or magnetic field is applied to the charge, then I was starting moving. Then the charge becomes the electric current. And electric current is measured in amperes. Then what is electric voltage? Electric voltage, what we are applying to the charge, then the charge starts moving, then the voltage is the reason for the movement of electrons or movement of charge. So the voltage is defined as the ability of a charge to do its work. To do its work means the movement of charge is current. The current will come because of the voltage. Then voltage is denoted with the letter V, work done by charge. Work done by charge. So electric voltage is also defined as the ability of charge to do its work as well as which causes the charge to flow is known as electric voltage. So V is equals to dW by dq, dW by dq. Joule, works units is joule, dW by dq. Q units are coulombs. Joules per coulombs is known as volts. Joules per coulombs is known as volts. Next, what is electric power? The rate of work done in an electric circuit is known as electric power. It is denoted by the letter P. With the letter P. dW by dt. The work done in an electric circuit per time. Now I am dividing and multiplying dW by dt with the dq. Now we can write dW by dt into dq by dq is equals to dW by dq into dq by dt, where dW by dq is voltage and dq by dt is current. So we can write this dW by dq as voltage and dq by dt as current. V into I. The electric power can also be defined as the product of voltage into current or work done per unit time or the total electric rate of electric work done in an electric circuit is also known as electric power. Power units are watts or joule per second. P equals to the product of voltage into current or the ability of voltage into current or the total amount of work done per unit time. Energy denoted with letter E. The total amount of work done. The total amount of work done in the circuit is known as energy. It is denoted with the letter E and product of power into time. Product of power into time, and energy units are joules. And energy can also be written as integration of power into time. Okay. Next, we are entering into the topic Ohm's law. Ohm's law states that at constant temperature and pressure, the current flowing through the conductor is directly proportional to the potential difference applied across the conductor. Let us consider a conductor. We are applying some potential difference V. When we are applying V, the current starts flowing through the conductor. At constant temperature, the current flowing through the conductor is directly proportional to the potential difference applied across the conductor. V directly proportional to I. V is equals to I into R. Ohm's law states that at constant temperature and pressure, the current flowing through the conductor is directly proportional to the potential difference applied across the conductor. So we have some limitations. where to apply this Ohm's law and where we should not apply this Ohm's law. Let us see the limitations. The definition itself, it is saying that the Ohm's law is having at constant temperature and pressure only. In it is having that the current flowing through the conductor is directly proportional to the potential difference applied across the conductor. So first limitations of Ohm's law is it is not applicable for temperature varying devices. Is not applicable for temperature varying devices. Is not applicable for temperature varying devices. Only at constant temperature it is applicable. Second point, it is applicable only for linear elements. Linear elements means when we increase the input of the system, the output should be increased automatically. So output of the system is directly proportional to the input of the system. If we decrease the input, output should be decreased. If we increase the input, output should be increased. For only linear elements, Ohm's law is applicable. It is applicable only for bilateral elements. Bilateral elements. Bilateral elements means the elements which allows the current to flow in both the directions. That elements are called as bilateral elements. Next, fourth point. It is applicable only at normal temperatures and normal pressure. Ohm's law is only applicable for at normal temperature and normal pressure devices only. So limitations of Ohm's law are it is not applicable for temperature varying devices. It is applicable for only linear elements. It is applicable for only bilateral elements. It is applicable only at a normal temperature and pressure only. No. Normal electric network elements or basic circuit elements now we are going to discuss. They are resistor, resistance, inductance, capacitance. Resistance, it is the property of a material which opposes the flow of current. Resistance opposes the flow of current. Opposes the flow of current. Inductance. Inductance, which inductance and capacitance are the storage elements where inductance will opposes the rate of change of current. Opposes the rate of change of current. Opposes the rate of change of current, and the energy stored in the inductors in the form of currents. Next, capacitance. Capacitance is the property of a material which opposes the rate of change of voltages. Which opposes the rate of change of voltages. Where resistor opposes the flow of current, inductors opposes the rate of change of currents, capacitor opposes the rate of change of voltages through them. So now we are going to discuss about what are active elements, passive elements. These also comes under the network elements. Active elements. Active elements are the elements which supplies the energy. Which supplies the energy. Which supplies the energy. Examples are energy sources like voltage source, and current source, which supplies the energy. Next, passive elements. Active element supplies the energy. Passive elements are consumes the energy. Example are resistor, inductor, and capacitor. Next, linear elements. As now I have discussed about linear elements, when input of the system increases, let us consider this is 0, 5, 10, 15, 20. When input is increased, the output should be automatically increased. Like 15. If we increase the input to 15, then output should be increased. The linear elements are the elements where output of the element is directly proportional to the input of the element. Next, non-linear elements, where linear elements are output of the system is directly proportional to the input of the system. But in non-linear elements, if a output does not follows the input, output is directly proportional to input are known as linear element. Otherwise, if output is not directly proportional to input, then the device or then the elements are known as non-linear elements. Examples of linear elements are resistor, inductor, and capacitor. Non-linear elements are diode, transistor. Next, unilateral elements. The elements which allows the current to flow only in one direction, they are called as unilateral elements. Allows the current only in one direction. Unilateral elements allows the current to flow only in one direction. They are called as unilateral elements. Bilateral elements which allows the current to flow in both the directions. Examples of bilateral elements are resistor, inductor and capacitor. Resistor, inductor and capacitor. Bilateral elements examples are diode, transistor. Next, lumped elements. The elements which can be physically separable are called as lumped elements. If we connect the circuit, we can remove the elements from this. They are called as lumped elements which can be physically separable. The elements which can be physically separable are known as lumped elements. Examples are resistor, inductor and capacitor. Next elements are distributed elements. The elements which cannot be physically separable are called as distributed elements. Cannot physically separable. Example or transmission line parameters. Basic network elements are 8 types. They are active elements, passive elements, unilateral elements, bilateral elements, linear elements and non-linear elements. Last, lumped elements and distributed elements, where active elements are the elements which supplies the energy, where passive elements are which the elements consumes the energy. Unilateral elements which allows the current to flow in only one direction, where bilateral elements will allows the current to flow in both the direction. Next, linear elements, output is directly proportional to the input. Non-linear elements are when the output is not directly proportional to the input. Lumped elements can be physically separable, which we can separate physically, where distributive elements cannot be physically separable. Next, we are going to discuss about resistance. Which is denoted with the letter R. The symbol of the resistance units ohms. Resistance is the property of a resistor which opposes the flow of current. Everywhere we are having the opposition. If you are doing any work, there is some kind of opposition. So in this conductor there is a opposition which opposes the flow of current. So this is resistance, and the units of the resistors are ohm. The resistance depends upon the resistivity of the material, length of the material, and area of cross section of the material, where rho is the resistivity of the material, expressed in ohm meter, L length of the material expressed in meters, where area of cross section expressed in meter square, where resistivity is ohm meter and length is meter divided by meter square. Meter gets cancelled, then resistivity units becomes ohms. Resistance, and the voltage formula for resistor is V from Ohm's law, V equals to I into R, where R is equals to V by I ohms. అయిందా 13? కట్ చేసుకుంటాను. అయిపోలేదు, నేను అయిపోయిన తర్వాత పిలుస్తాను, మీరు వెళ్ళండి. Next, connections of a resistor. How we can connect the resistors? There are two connections. They are series connection and parallel connection. Series and parallel connection. Series and parallel connection. Let us consider two resistors, R1 and R2. In series connection, every element is having two terminals, starting terminal and ending terminal. The starting terminal is represented with A of first element, and ending terminal of the element is represented with A dash. Next, R2 is represented with B. Starting terminal is represented with B and ending terminal is represented with B dash. A dash, B dash. This ending terminal of one element or ending terminal of first element is connected to the starting terminal of second element, then that connection is known as series connection. When ending terminal of first element and starting terminal of the second element are connected, that connection is known as series connection. Where in parallel connection, starting end of the first element and starting end of the second element, ending end of the first element and ending end of the second elements are connected together, then that connection is known as parallel connection. Series connection means ending end of the first element and starting end of the or starting terminal of the second element connected together. This connection is known as series connection. When starting end of the first element and starting end of the second element, ending end of the first element and ending end of the second element are connected, then that connection is known as parallel connection. R1, R2, V. In series connection, when we supply the voltage, automatically current flows through the resistors. The current flowing through the resistance in R1 and R2 are same. The current flowing I is flows through the R1 and I is flows through the R2, but voltage will drop across the resistors. The voltage drop across the resistor 1 is V1 and the voltage drop across the resistor R2 is V2. So then V supply voltage V is equals to V1 plus V2. From Ohm's law, V is equals to I into R, as V1 is denoted as I into R1 and V2 is represented as I into R2, and V is a I into R equivalent. I into R equivalent equals, now I am separating or taking common I as common and R1 plus R2, where I and I gets cancelled. R equivalent is equals to R1 plus R2 ohms. Voltage drop will occurs across the resistor 1 and resistor 2 as V1 and V2. The supply voltage V is equals to V1 plus V2. V from Ohm's law, voltage can be written as I into R. The voltage drop across the V1 is known as current flowing through the R1, and then it is V1 is represented with I into R1 plus V2 is represented as I into R2. Now I am taking common as I as common and R1 plus R2, where I gets cancelled. When two resistors are connected in series, then equivalent resistance are R1 plus R2. Let us see. When the two resistors are connected in parallel, what is the equivalent resistance? This is R1 and this is R2, supplying voltage V, current flowing I. The I in a series connection, voltage drop is occurred across the resistors. In parallel connection, the current is divided and voltage is same across the resistors. So I is divided as I1 plus I2. I1 is flowing through the resistor R1 and I2 is flowing through the resistor R2. From Ohm's law, V is equals to I into R, then I equals to V by R. Now I is written as V by R equivalent and V1 is written as V1 by V by R1 and I2 is written as V by R2. Now I am taking common V as common, 1 by R1 plus 1 by R2. V and V gets cancelled. 1 by R equivalent is equals to 1 by R1 plus 1 by R2. R equivalent is becomes no R1 R2 by R1 plus R2. When two resistors are connected in series, the R equivalent will be R1 plus R2. When two resistors are connected in parallel, the R equivalent will be R1 R2 by R1 plus R2. Inductance represented with letter L. Inductance is the property of the inductor which opposes the rate of change of current through it. Which opposes the rate of change of current through it. When the word rate of change of occurs, then will take place the differentiation. First of all, we see the symbol of inductor represented with the letter L. Units of inductance Henry. Voltage formula for inductor is V directly proportional to the rate of change of current flowing through it. Then V is equals to the L DIL by current through inductor by dt. Okay, this is the voltage formula. From voltage formula, we have to write current formula. The L is multiplying this side. When it is goes to this side, it will become division. 1 by L V. Next, DIL is equals to 1 by L V dt. Next, IL will become this side differentiation. When it is going to that this side, then it becomes integration. These are the current and voltage formula for inductor. Now we are see the series and parallel connection for inductor. Series means ending end of the first element should be connected to the starting end of the second element. The inductor and capacitor are the storage elements, and these are applied when AC supply is given to them. Voltage, current flows through them. In series connection, current is same across the current flowing through the element are same, but voltage drop will occur across the elements. VL is equals to VL1 plus VL2. From Ohm's law, we can write as previous. What is the voltage formula? V equals to L di by dt. V is equals to L dl by dt. This formula is represented here. VL, L equivalent dil by dt is equals to VL1. Voltage across the inductor 1 is represented as L1 dil by dt plus L2 dil by dt. Now I am taking dil by dt as common. L1 plus L2, where dil by dt and dil by dt gets cancelled. L equivalent is equals to L1 plus L2 Henry. When two inductors are connected in series, the equivalent inductance will becomes L1 plus L2. In parallel connection, the starting end of the first element should be connected to the starting element of the second element, and ending end of the first element should be connected to the ending end of the second element. Voltage is applied. Current is divided as IL1 and IL2, and voltage across the inductors are same, V. I is equal IL1, IL equals to IL1 plus IL2, where current equation is 1 by L integration of V dt. So 1 by L integration of V dt is represented in the place of IL and IL1, IL2. Now I am taking integration of V dt as common. Integration of V dt and integration of V dt get cancelled. 1 by L equivalent is equals to 1 by L1 plus 1 by L2. L equivalent is equals to L1 L2 by L1 plus L2 henries. When two inductors are connected in series, equivalent inductance is L1 plus L2 henries. When two inductors are connected in parallel, L equivalent will be L1 L2 by L1 plus L2. Capacitance. Capacitance is represented with letter C. Capacitor is symbol is consist of two plates. One positive conducting plate and negative conducting plate. In between them we are having dielectric material. Units of capacitance is farads. Capacitor is a storage element. The property of the capacitor is to oppose the rate of change of voltages. It opposes the rate of change of voltages. The current flowing through the capacitor is directly proportional to the dVc, voltage across the capacitor, by dt, where IC is equals to C dVc by dt. This is capacitance, the current equation of the capacitor, and from current equation we have to find the voltage. dV by dt is equals to 1 by C IC. dV is equals to 1 by C IC dt, where V is equals to 1 by C integration of IC dt. These are the voltage and current formula for capacitor. Now we will see what will happen when two capacitors are connected in series and two capacitors are connected in parallel. In series connection, we know that already that ending end of the first element should be connected to the starting end of the second element. C1, C2, voltage applied across the capacitor. C1 is Vc1, C2 is Vc2. We already know that current flowing in the series connection will be same throughout the elements. Now Vc1, Vc is equals to Vc1 plus Vc2, where Vc, voltage formula for capacitor is 1 by C integration of IC dt. 1 by C integration of IC dt. Plus 1 by C2 integration of IC dt. Now I am taking integration. Integration of IC dt as common. integration of IC dt as common, then remaining terms are 1 by C1 plus 1 by C2. Now integration of IC dt and integration of IC dt will be cancelled. 1 by C equivalent is equals to 1 by C1 plus 1 by C2. So C equivalent is written as C1 C2 by C1 plus C2 farads. When two capacitors are connected in series, C equivalent will be C1 plus C2 by C1 C2 by C1 plus C2. If two capacitors are connected in parallel connection means starting end of the one element should be connected to starting end of the second element, and ending end of the first element should be connected to ending end of the second element. In parallel connection, current is divided as IC1 and IC2. Voltage across the capacitor will be same as VC. So IC is equals to IC1 plus IC2. The current equation for the capacitor is C dVc by dt. C1 dVc by dt plus C2 dVc by dt. Now I am taking dVc by dt as common. dVc by dt as common. Remaining terms are C1 plus C2. Now I am getting cancelling the dVc by dt. So C equivalent will become C1 plus C2 farads. When two resistors are connected in series, R equivalent is R1 plus R2. When two resistors are connected in parallel, R equivalent is R1 R2 by R1 plus R2. When two inductors connected in series, L equivalent is L1 plus L2. When two inductors are connected in parallel, L equivalent is equals to L1 L2 by L1 plus L2. When two capacitors are connected in series, C equivalent will be C1 C2 by C1 plus C2. When two capacitors are connected in parallel, then C equivalent will be C1 plus C2. Today we have learnt about basic concepts of elements of electrical and electronics engineering, like what is charge, voltage, current, power, energy, and Ohm's law. Next, basic elements of electrical network. Basic elements: resistor, inductor, capacitor, and active elements, passive elements, linear, non-linear, unilateral, bilateral, and lumped and distributed elements and their examples. And in elaboration to the resistance, we have seen the different connections: series parallel for resistance, and series parallel connection for inductor, and series parallel connection for capacitor, and what will be their equivalent resistance, equivalent capacitance, equivalent inductance when they are connected in series and parallel. Current and voltage equations for resistor, inductor, and capacitor we have seen today. In next class we will continue with the problems. Thank you.